Hello friends, today in this fourth lecture of the Laplace Transform we shall discuss the two remaining properties of the Laplace Transform followed by some working examples. So the properties are, if property 6, 5 properties we have seen. If Laplace transform of f of t is f of s, then the Laplace transform of integral 0 to t, say f of u du, is equal to f of s by s. This is the property of Laplace transform of the integrals. This is integral 0 to t f of u du. Laplace transform of this integral is nothing but f of s by s. Shall prove this. Laplace transform of integral 0 to t f of u du, by definition it is equal to integral 0 to infinity e raised to power minus st into this function, integral 0 to t f of u du dt. Now how to integrate this? First, one of the functions is exponential e raised to power minus st and another function is this integral 0 to t f of u du. So we shall integrate this by parts, choosing this function as the first function and this is the second. So first function integral 0 to t f of u du into integral of e raised to power minus st is e raised to power minus st upon minus s minus integral of 0 to infinity. The derivative of first. What would be integral of derivative of first? F of t dt into integral of this e raised to power minus st upon minus s. So that is, well, limits are 0 to infinity. So for t equal to infinity, e raised to power minus infinity is 0. So for upper limit it is value is 0. For the lower limit t equal to 0, integral 0 to 0 is 0. So first term is 0. This minus minus plus. So this is equal to integral 0 to infinity e raised to power minus 1 by s times e raised to power minus st into f of t. This s is independent of t. It is constant. So it is nothing but f of s by s. This is Laplace transform of f of t. So that illustrates simply by integrating these two functions, choosing this as first and exponential as the second one. So Laplace transform of the integral 0 to t f of u du is always equal to f of s by s. Just divide f of s. Just divide Laplace transform of f of t by s. You directly get the Laplace transform of integral 0 to t f of u du. And now let us come to the last property. Laplace transform of derivative we have seen, now Laplace transform of integrals we have seen, now Laplace transform of derivative. If Laplace transform of f of t is f of s, then number one, Laplace transform of ddt of f of t or Laplace transform of f prime of t is equal to s into f of s. Formula is minus f of 0. Number 2, Laplace transform of d square by dt square of f of t or Laplace transform of f double prime of t is equal to s square into f of s minus s into f of 0 minus f prime of 0. Third one, Laplace transform of f3 prime of t. Third derivative of f of t with respect to t is s cube of f of s minus s square into f of 0 minus s into f prime of 0 minus f double prime of 0 and so on. We can, using this formula, we can find out the Laplace transform of consequent derivatives. This formula for the first derivative, this is the second derivative, this is the third derivative. Now we shall prove this. I shall illustrate this first one. Proof. Laplace transform of f prime of t. By definition, integral 0 to t e raised to power minus st into f prime of t dt. Now integrate this by choosing this exponential as the first function and this is a second function. So first function is e raised to power minus st into integral of f prime of t, is f of t, first function, into integral of second. The limits are from 0 to infinity, it should be infinity, minus integral of derivative of first e raised to power minus st. Derivative of e raised to power minus st is e raised to power minus st with respect to t is into minus s into integral of second. For upper limit, e raised to power minus infinity is 0. For lower limit, e raised to power 0 is 1 into f of 0. So for upper limit it is 0. Minus 1 into f of 0 minus. Minus minus it is become plus. S is independent of t and integral 0 to infinity e raised to power minus st f of t is Laplace transform of f of t denoted by f of s. So it is equal to s into f of s minus f of 0. So that is how we obtain the Laplace transform of f prime of t. Similarly, we can prove this f double prime and f3 dash also. So, these are the 7 properties of the Laplace transform. First, shifting property. Second, shifting property. Scaling property. Multiplication by t property. Division by t property. Laplace transform of integrals. Laplace transform of derivatives. These properties we have discussed. Now, using these properties, we would be solving some examples, working examples. Obtain Laplace transform of e raised to power minus 2t into sine square of 3t. Whenever function is multiplied by sine square t, any function is multiplied by exponential, we always use the first shift property. So here, making use of first shift. So first of all, we would be determining the Laplace transform of sine square of t. What is sine square of 3t? Laplace transform of sine square of 3t is equal to Laplace transform of 1 by 2 times 1 minus cos of 6t. Because sine square 3t is half of 1 minus cos 6t. Formula for sine square t is half of 1 minus cos of 2t. So using that formula. So this is further equal to 1 by 2 times Laplace transform of 1 is 1 by s. Cos of 6t is s upon s square plus 36. This is just Laplace transform of sine square of 3t. Therefore, by FSP means by the first shift property, the Laplace transform of e raised to power minus 2t into sine square 3t is equal to f of s plus 2. This is f of s. In f of s, put s equal to s plus 2. So that is equal to 1 by 2 times 1 upon, replace s by s plus 2 minus s plus 2 upon s plus 2 whole square plus 36. So, this is the required Laplace transform of e raised to power minus 2t into sine square 3t. Next example. Second, Laplace transform of ddt of sine of t by t. Here, as sine of t is divided by t, so we would be using the division by t property. It is divided by of sine t. Then Laplace transform of derivative of sine of t by t. So first and foremost, we would be finding out Laplace transform of sine t. Laplace transform of sine of t is 1 upon s square plus, this is f of s. Therefore, by division by t property, Laplace transform of sine of t by t, the formula is, the property said, it is integral s to infinity f of s ds. So it is a integral s to infinity f of s is s square plus 1. Integral ds upon s square plus 1 is tan inverse of s. Limits are from s to infinity. For the upper limit, tan inverse infinity is pi by 2 minus. For lower limit, s is equal to s, so it is tan inverse s. So pi by 2 minus tan inverse of s is cot inverse of s. So what we have seen, Laplace transform of sin t by t is equal to cot inverse of s. This is f of s. Therefore, now the formula for the Laplace transform of the first derivative I am using. The Laplace transform of d by dt of sine of t by t, the formula says it is s into f of s minus f of 0. That is equal to s into cot inverse of s minus f of 0. F of 0 means value of f of t at t equal to 0. What is f of t? It is sine of t by t. Sine of t by t. So, value of t at t equal to 0 of sine of t by t means it is limit t tends to 0 of sine of t by t. F of t at t equal to 0, s into cot inverse of s minus limit t tend to 0 sine of t by t, or s into cot inverse of s minus 1. That is how we determine the Laplace transform of ddt of sine of t by t. Third example. Laplace transform of t into e raised to power minus 3t into sine of 4t. Here, multiplication by t property I am using. E raised to power multiplication by e raised to power minus 3t, the shift property first. So sine of 4t is f of t here. So Laplace transform of sine of 4t. What is it? It is 4 upon s square plus 16. Therefore, Laplace transform of t into sine of 4t. Now, see here, I am not finding out the Laplace transform of e raised to power minus 3t into sine 4t at this step. Perhaps I am first multiplying by t and using multiplication by t property. So multiplication by t property, it is dds of minus d by ds of this f of s, 4 upon s square plus 16. That is, this is by multiplication by t property. So it is minus 4 into this derivative is minus 2s upon s square plus 16 whole square. So it is equal to 8s upon s square plus 16 whole square. This is s square plus 16 s to power minus 1. So it is minus 1 into s square plus 16 s to power minus 2 into derivative of s square, it is 2s. So this is the Laplace transform of t into sin 4t. Now by first shift property. First shift property, the Laplace transform of e raised to power minus 3t into t into sine of 4t is equal to f of s plus 3. So in this f of s, replace s by s plus 3, that is equal to 8 times s plus 3 upon s square plus 16 whole square. That is the Laplace transform of this function. Next. Fourth, Laplace transform of t square plus 2t plus 1. Laplace transform of t square is 2 upon 2 factorial upon s cube, 2 factorial s cube plus 2 times Laplace transform of t is 1 by s and Laplace 2 by s, 1 upon s square and 1 is 1 by s. Laplace transform of t is 1 upon s square and that of 1 is 1 by s. Next, obtain Laplace transform of t into cos h of 2t, that is equal to Laplace transform of t into cos h 2t is 1 by 2 times e raised to power 2t plus e raised to power minus 2t. So it is equal to 1 by 2 times Laplace transform of t into e raised to power 2t plus Laplace transform of t into e raised to power minus 2t, splitting into two different terms, that is equal to 1 by 2 times Laplace transform of t is 1 upon s square and this is 1 by s, 1 upon s square. So Laplace transform of t into e raised to power minus 2t will be f of s minus 2. So 1 upon s square replaces by s minus 2 whole square plus here similarly 1 upon s plus 2 whole square. So that is the Laplace transform of t into cos h of 2t. So these are the enough examples for this lecture. You might have a very clear-cut idea regarding the definition and how we solve the examples. Thank you very much. Thank you.